welcome to the first video on building information modeling. And in today's video, we are going to dive into knowing what is building information modeling and how building information modeling, that is BIM, is different from the traditional construction practices. So, in order for us to know how BIM is different from the traditional construction practices, we first need to know what are the traditional construction practices that are going on in the industry, and furthermore we'll learn why are companies switching from traditional construction practices to BIM. Okay, so let's get to know the traditional construction practices in the industry. So we have this client who approaches the architect. Now the architect is supposed to plan the space, that is floor plans. We have various other plans that are produced by the architect that we will get to know, that we will know as we progress into the course. Okay, so he's responsible for space planning. He looks after the aesthetics of the building, in the sense the exterior elevation, the facades, the projections. He looks after the landscaping part of it, and he looks after the sustainability. Now these drawings that are produced by the architect are passed on to the structural engineer. So what is the role of a structural engineer now? He has to look after the stability of the building. Now when it comes to stability of the building, what the structural engineer does is, based on the drawings received from the architect, he is going to design the foundations, columns, plinth beams, slab beams, slabs, staircases, shear walls, and various other structural components. So once the architect has designed and drafted his drawings, he's going to pass it on to the structural engineer. The structural engineer is going to produce the structural drawings. Make a note that these are the traditional construction practices, so these are happening in 2D, not in 3D. These are in 2D, and these 2D drawings, okay, the architectural drawings, the structural drawings. Further on, we also have the MEP drawings, that is mechanical, electrical, and plumbing drawings. So all these drawings cumulative, now these MEP drawings are produced by the MEP engineer. So all these drawings cumulatively, that is the architectural drawing, the structural drawings, the MEP drawings, are passed on to the contractor and the project manager. Now these contractors and project managers are supposed to execute these drawings onto the site. They are supposed to turn these drawings into reality on site. So let's just have a look at the 2D drawings, how these 2D drawings are produced by architects, structural engineers, or MEP engineers. So this is typically a 2D floor plan, which is usually produced by the architect. Then we have the electrical plan, which is produced by the electrical engineer. You can see these are all in 2D. These are all in 2D. Then we have the structural plan. We can see the foundation here, and we have various other components here in the structural drawing. We will learn how to read structural drawings, architectural drawings. All this will come in the further part of the series. Okay, so we have the architectural 2D plan, we have the structural 2D plan, and we have the electrical 2D design or 2D layout. Okay, we also have various other 2D drawings, such as we have the beam layout here, we have the beam cross sections here, beam cross sections again, we have the center line drawings, here, we again have the beam layout, we have the foundation, this is the elevation and section foundation. We also have the foundation plans, and there are various other drawings that are produced in 2D. Now these 2D drawings are passed on to the contractors and project managers, and they are responsible for converting these drawings into reality on site. And these project managers and contractors are supposed to convert these 2D drawings into reality on site. Okay, so now what is the problem? Like, we have the drawings, we have the project managers, we have the contractors, and they are executing these 2D drawings on site. So what is the problem exactly? So what happens is during the execution of these 2D drawings on site, errors are occurred on the site. Like for example, let's say we have underground conduits running through the running underground, and we have the foundation. So what happens is there are chances that when we are only referring to the 2D drawings, the electrical lines or any other service that is running in the underground, they may pass through the foundation. And foundation being a very critical part of the structure, usually we don't pass any services through the foundation. So this error is usually spotted when we are executing these drawings, 2D drawings, onto the site. So what do? We just stop the construction, we go back to the architect or to the respective engineer, and we tell him that this is the problem that is occurring. So then the architect makes the respective changes, or let's say the electrical conduits are passing through the foundation. So we have to inform this to the MEP engineer. So the MEP engineer is going to make some changes in the elevation of the electrical conduits so that it doesn't pass through the foundation. But and then the structural engineer is informed, and then we can resume the construction. During this process, there is a lot of time consumed. We have to go to the MEP engineer, we have to go to the structural engineer, get it approved, and then start the construction again. So when we switch to BIM, what happens is, like when we talk about building information modeling, as you can see the model here, we work in 3D. So this is one of the 3D models. This is the architectural 3D model. This is the MEP 3D model, as you all can see here. And we have the structural 3D model here. Okay. So in building information modeling, we are working with 3D models. We're not working in 2D here. We are working with 3D models here. So when we are working in 3D, let's say we have the architectural 3D model, we have the MEP 3D model, which is designed by the MEP engineer, and we have the structural 3D model, which is designed by the structural engineer. At the end, what we do is we merge all these three models together. I'm going to show you all at the end of the video how the models are all merged together, and we get the exact replica of the model that is to be constructed on site. So in this model, we can clearly see how the conduits are running through the foundations. Let's take one more error. Let's say we have huge HVAC ducts, and they are passing through the beams. So let's say the size of the ducts is too large, and they are passing through the beams. Now, beam being a structural component is again critical. So we may or may not pass the services through these beams. So what happens is when we are doing the 2D coordination, when we are working with 2D drawings, we may or may not spot the error that the ducts are passing through the beams. But when we are working in 3D, when we merge all the three models together, that is the architectural model, the structural model, and the MEP model, we can clearly see what service is running through which component. And if the duct is passing through the beam, we can clearly see in the model that the duct is passing through the beam. And when we spot these errors, like what are the errors? The electrical conduits passing through the foundation, or the ducts passing through the beams, or various other errors. We are spotting these errors even before starting the construction. So what we do is we produce our 3D models, and we have a meeting together. All the stakeholders, that is the architects, structural engineers, MEP contractors, all of them, they get on a meeting, and they check the whole 3D model, whether any services are clashing with each other or are not passing along appropriate locations. Okay. And these errors are spotted then and there itself, even before the construction is started. So you'll get to know even before the construction is even before we are starting the construction, we already have solved all the errors. So the speed of construction increases. We don't have to stop the construction anywhere. So this is one advantage I told you all about how BIM is advantageous over the traditional construction practices. So now we all know why companies are switching from traditional construction practices to BIM. So there are various other advantages which are which we can get with if when we implement BIM onto our projects. So in traditional construction practices, we made use of 2D drawings. In BIM, we make use of 3D drawings, okay, or 3D models, you can say, architecture, structure, MEP, and various other models, okay. So this is done. We now know what are traditional construction practices and what is BIM now. Okay, so we also know how BIM is different from the conventional construction practices. Let's get to know more about BIM. So what is BIM? BIM is a strong combination of concepts, collaboration, technology, standards, and policies. Concepts: we design the architectural floor plans, the structural layouts. What do I mean by concept? Concept in the sense how we decide the room sizes, we decide the location of the rooms, we decide where the door is to be placed, and like the exterior facades. All these are done in the conceptual stage. We also have deciding the sizes of the foundations, beams, slabs, columns. So all these are concepts that we develop. So the first step in BIM is we develop the concepts first. Once we develop these concepts, we produce the drawings out of these concepts. And once we produce the drawings, we may also produce 3D models out of these drawings. Once we do produce these 3D models, as I told you all, we just merge all the three models. We merge all the three models, and once we merge all the three models, we just get a replica of the exact structure that we want to construct on site. Okay, so we just get into a meeting, that is collaboration, and we see if there are any potential errors that can be occurred while the execution of these drawings and models take place on site. So we get into a meeting, all the stakeholders, and we submit all our models. They are merged together. You need not worry how these if you don't know how these models are merged, we will get to see this. I will be showing you how the models are merged and worked on. Okay, so once the collaboration is done, once we rectify all the errors, we inculcate technology and digital processes. That is, we use various softwares like Revit, Navisworks, Dynamo. We have various BIM softwares, Civil 3D, Twin Motion. So all the using all these softwares, we produce 3D models out of it. Okay, and then we have standards and policies. Now, unlike traditional practices, we have certain defined standards for BIM. Okay, you just for example, if I tell you about one standard, you just can't name any component whatever name you want. There are certain codes which you'll need to follow, a code of conduct that you'll need to follow to name every component of the building or the models as well. You'll need to follow a code of conduct, after which the model has to be named. And there are various other policies based on the codebook ISO 19650. So we will be covering the codebook as well, but in the further sessions. Okay, so BIM is a combination of concepts, collaboration, technology, standards, and policies. So all these together, as you can see here as well. So we have 3D, we have 4D, we have 5D. Until 2D, it was conventional construction practices. When we get into 3D, when we get into 4D, when we get into 5D, 6D, 7D, 8D, that is incorporated BIM into a project. So what are these parameters? 3D is nothing but producing 3D geometry models. 4D, 5D, 6D, we will see as we progress into the sessions. Okay, so uh, what is BIM? We just understood, we got an overall outlook of what BIM is. Okay, but now what is BIM? If we actually get to see, building information modeling is a digital representation of physical and functional characteristics of the building or infrastructure. That is, if we talk about what is BIM, it represents the model itself, represents the physical and functional characteristics. That is, let's say we have a wall which is 9-inch thick. Okay, so the same wall you can see in the model as well, as it is as it is to be constructed on site. So whatever the structure that you want to construct on site, the exact thing you can see in the software as well. Unlike, we cannot see this in 2D coordination or in 2D drawings, but when it comes to building information modeling, we can clearly see whatever we want to construct on site, everything can be seen on the software itself. So it involves the creation and use of 3D model that integrate information about various aspects of the construction project, including geometry, spatial relationship, geographical location, and quantities. We can calculate using building information modeling, or when we incorporate BIM onto our projects, we easily get the quantities. You all must have done estimation and costing in college, wherein on the paper you all wrote down length into width into breadth, and then the quantity multiplied with the cost. We directly get the quantities from the we can get the quantities directly from the model itself. And what does this model also consists of? It consists of geometry. It has the exact length, breadth, depth of the wall or any other component of the model. Okay. And geographical information also you can give, like exactly at what point the building has to be constructed. It's not just about 3D, it encompasses data and information about the building. Okay. So what do I mean by that? Let's say I have a wall. So what is a wall made up of? It is made up of brickwork and external plastering and internal practice plastering. So we can highlight what bricks are used to construct that wall. What is the plaster thickness? What is the material of plaster that is used to construct that wall? Who is the manufacturer of that plaster? Who is the manufacturer of the entire wall? Everything can be incorporated in a model. So basically, when it comes to BIM, along with the geometries, we also have information associated with those components. So cost saving during the operational phase of the project used with digital twin. As I told you all in the like previously, all the errors, like majority of the errors, I cannot say all the errors, not 100% of the errors, majority of the errors which would have caused delay in the construction if we used 2D drawings, they can easily be spotted when we are doing the 3D coordination. And when they are resolved then and there itself, the speed of construction increases. And when the speed of construction increases, the cost also decreases. Okay. So next thing, why are the ASC industries steadily switching to BIM? Okay. So improved collaboration, as I told you all, when we okay, let me just read this first. Improved collaboration. BIM promotes better collaboration and communication among different stakeholders involved in a construction project, including architects, engineers, contractors, and facility managers. What do I mean by that? As I told you all, the architect produces his architectural model, structural engineer structural model, MEP engineer MEP model. All of them get into a meeting common, it can be online or offline, and they showcase them, they just merge all their models, and they look for the potential errors that can be caused, and those errors are solved then and there itself. So this is one advantage of using improved collaboration. Okay. This is one of the advantages when we talk about improved collaboration. Okay. So we have enhanced visualization. So in 2D drawing, when we talk about 2D, BIM provides a three-dimensional digital representation of the building or infrastructure, allowing stakeholders to visualize the project more accurately. So when we talk about traditional 2D practices, what we can see is we cannot visualize the exact project into a software. But with the help of building information modeling, we can visualize everything that is to be constructed on site. Like the walls that are constructed on site are exactly seen as it is, as they are to be constructed on site into the software itself. We can see the ducts, the structural components, MEP components, everything exactly how they are to be executed on site. Okay. So we can get a overall outlook of how the building looks like, and we can also spot potential errors that may be caused during the construction phase. Okay. Then clash detection and conflict resolution. BIM enables clash detection, helping to identify and resolve conflicts or clashes between different building systems, such as structural, mechanical, and electrical before construction begins. This reduces the likelihood of cost errors and rework during the construction phase. This part I've already explained. That is, let's say we have a huge ductwork which is passing through the beam. Now, when this ductwork is passing through the beam, when we are using only the 2D drawings, this error may be spotted during the construction phase. Now, when this error is spotted, we have to go back to the MEP engineer. We have to ask him to reduce the size of the duct, because beam is a structural component, and we may or may not pass such a huge duct through the beam. So what we do is we approach the MEP engineer, ask him to reduce the size, or we ask him to flatten the duct size. We ask him that, or we do something, or we reduce the height of the ductwork so that it passes below the beam and not through the beam. Okay, so or sometimes the structural engineer may like analyze the stability and say that it is fine if the ductwork passes through the beam, but it all depends on the structural engineer. So let's say when we are using 2D drawings, this error may be potentially be spotted during the execution phase. But when we use building information modeling, when we are doing the coordination in 3D, such errors can be spotted during the even before starting the construction. So using BIM, we are eliminating a lot of error. So rework, what do I mean by rework? So during the construction stage, let's say I had to bring down the uh, height of my ductwork so that it doesn't pass through the beam. That is rework. So we are just avoiding the rework here when we are using building information. Cost saving, you can just go through the paragraph. Cost saving, when we are increasing the speed of construction, when we are increasing the speed of producing drawings, we are obviously saving the cost as well. Efficient project management helps in tracking progress, managing changes, and ensuring that all stakeholders are working with most up to date data. So one of the examples is, let's say we are working in 2D, and when we are working in 2D, uh, let's say the architect moves the wall by certain inches or by certain feet. Okay, now this will be passed on to the structural engineer, and the structural engineer has to look into it, and then he has to make the appropriate changes. But when we talk about building information modeling, when the wall in the model, in the 3D model, is moved in the federated model, what is the federated model? The combined model. Automatically the structural engineer also get to know that the wall is moving away, and accordingly he can make the changes in the beam as well. That is, even he can move. Otherwise, in traditional construction practices, what would have happened, he had to do it on an architect had to make the changes, inform the structural engineer would have done the changes again. But here we are working in a collaborative environment. That is, the changes that are done by the architect are like automatically reflected in the model, and when these changes are reflected in the model, the structural engineer can make the uh, appropriate changes according to the changes that are done by the other stakeholders. Sustainability and energy efficiency, it can be used to analyze and optimize the environmental performance of the building, contributing to sustainable design and construction practices. Like we can get the energy efficiency, we can get to know about the material usage, and we can also get to know about the carbon footprint of the building here. So facility management and maintenance. So when we talk about facility management and maintenance, beyond construction, BIM support, like let's say we have like okay, beyond construction, BIM supports facility management by providing digital twin model, okay, detailed digital model that includes information about the building components and systems. This aids in ongoing maintenance, renovation, and future planning. Let's say we have a roof here and we have a ceiling here, and between the roof and the ceiling we have services running. Okay, now let's say there is a leakage. Okay, there is a leakage, and we don't know from where, like what components are there over the ceiling. So when we get access to the, let's say, to the 3D to the federated model or to the as built model, we can actually get to know in the software itself that which component is placed where, on the basis of which maintenance and renovation and future planning becomes very easy. So global collaboration, BIM facilitates collaboration on global scale, allowing teams from different locations to work together seamlessly. This is especially important for large scale projects. So let's say we have various projects working on various teams working on one project, that is the architectural team, structural team, MEP team, and various other teams working particularly only on one project. So we can have one team working in Canada, one team working in Europe, one team working in India, but still with the help of BIM technology, we can all collaborate and work together even from different locations. So usually for large projects we have different teams working from different locations. So when we implement BIM, it is very easier for us to collaborate all the teams together. And last point, market demand and standards. As I told you all previously about the advantages of BIM over conventional practices, we can see that a large number of industries are steadily moving towards BIM technology, and in future we can see that a lot more industries will be switching to BIM. The reason being speedy constructions, saving in costs, and various other factors which I just told you about. Okay, so today what we learned about is what is BIM, what are the traditional construction practices, and we also learned how BIM is different from the traditional construction practices, and we also learned why companies are moving steadily towards BIM. So we will start off with the concepts, and we will start off with the modeling part in softwares from tomorrow, and simultaneously we will also be studying the theory part of building information modeling. So this is going to give you all a complete overlook of how BIM is carried out in the construction, or BIM is implemented on project. Okay, so it will continue in tomorrow's videos. Thank you so much.